Looking at any star in the night sky, you'd think that that tiny pinprick of light will be there forever. And from a human perspective, it will. However, stars do die at some point, even if the process takes billions, or in some cases, trillions of years. The way a star dies depends on its mass, and it ranges from just fizzling out to producing one of the most spectacular cosmic events possible. Now, before we get into all of this crazy stuff, I would appreciate if you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. One thing before we start. The mass of a star is measured based on solar masses. In other words, how many times as massive the star is compared to the sun. Now with that out of the way, let's work our way from the bottom up. The lower limit for a star, that is, an object that produces nuclear fusion in its core, is 0.08 solar masses, and such stars can live for over 10 trillion years, so a length comparable to the time frame of star formation itself. From here up to about 0.3 solar masses, stars will burn slowly for trillions of years, and once out of fuel, are expected to simply fizzle out and become white dwarfs, so a star type that I'll get into more detail about in a bit. I say they're expected to do that because the universe is only 13.8 billion years old, so we don't actually know what's going to happen to these stars. One last thing. These stars may last a long time, but they're among the coolest and dimmest stars that can exist. Between 0.3 and 8 solar masses, things get a bit more interesting. These stars burn their fuel hotter and faster than their dimmer counterparts, so their lifespans are generally measured in the billions instead of the trillions. Once their main sequence, that is, the part of their lifetime where they fuse hydrogen in their core, ends, instead of fizzling out, these start to expand. The final phase of these stars' lives are called red giants, and during this phase, they can expand to several hundred times their original size, which at the same time getting significantly cooler, though still way too hot for human survival. After spending a few million years in this phase, they get so big that they basically expel their outer layers into space, leaving behind the white dwarf. Now before we get into the most massive stars, we need to know, what exactly are white dwarfs? Well, they're basically star corpses. They are inert hunks of mass that can't fuse, and instead slowly radiate away their heat into space. These hunks of mass start off very hot, but over hundreds of trillions, perhaps even quadrillions of years, they cool down until they reach the ambient temperature of the universe, which is about minus 450 degrees Fahrenheit. White dwarfs are also very massive, containing a significant portion of the star's original mass, but are also only about the size of Earth. So 1 teaspoon of matter is heavier than a car. Alright, now to get into the last subset of star death, supernovae. I've already covered this topic in a video a couple weeks ago, so if you want more detail of this, go watch that. But the gist is, star over 8 solar masses fuses very quickly, it expands, it fuses extremely heavy elements in its core, and eventually it blows up and becomes a neutron star or a black hole. Keep in mind, that all takes place in just a few million years. And that wraps it up for this video. As always, I would appreciate if you'd like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.